Hello, my name is Caitlin Deller. I'm a senior environmental science student at Worcester State University. I have been working with Dr. Laura Reynolds from the Department of Earth, Environment, and Physics in order to analyze the carbon storage of 2 coastal lakes. And this project was funded by the Worcester State Foundation and done in collaboration with Dr. Lauren Simpkins and Marion McKenzie from the University of Virginia. The main goals of my project were to determine A, the carbon storage of these lakes, and B, any changes that may have occurred at these lakes over time. This project was also part of a much broader project, which is analyzing environmental changes that have happened in this region. The importance of this project is that carbon storage by lakes is not typically accounted for in carbon budgets globally. However, they've been found to be major terrestrial stores of carbon. The figure shows the rates of organic carbon burial in both lakes and reservoirs. And from this, you can see there is a wide variance of how much and how long it takes to store these carbons, but they are in fact carbon, but lakes and reservoirs are in fact carbon sinks. There are 2 sites that were sampled in this location. They were both in the Puget Sound area of Washington. The first site was West Beach Lake, which is located along a public road and is at sea level. From this location, 4 sediment cores were taken, with the maximum depth being 75 centimeters. The second location was Oliver Lake, which is located at the top of the cliff. From here, 2 sediment cores were taken, with the maximum depth being 60 centimeters. This is a couple more views of the sites, with the image on the left being where the sites are relative to the Puget Sound, and the images on the right being Google Earth images of the 2 lakes. And as you can see, West Beach Lake and on the top and Oliver Lake on the bottom have a wide difference in the elevation that they are located at. So the lab work that I did to find the carbon amounts of these sediments was, first I would weigh the crucible, and then I would sample 1 cubic centimeter of wet sediments from each centimeter of the core. I would then measure the wet weight, dry the samples for a minimum of 12 hours at 100 degrees Celsius, and then weigh the samples again to get the dry weight. The image on the right, the sediments at the top, are right after a dried sample. I have dried them. I would then place the crucibles in a furnace and burn them at 550 degrees Celsius for 6 hours. After the samples had cooled to room temperature, which is about 20 degrees Celsius, I would weigh them again to find the loss on ignition, or LOI weight. This is how much organic matter has been burned off. The sediments on the bottom of the image are right after an LOI weight. And as you can see, there's a difference in both the color and the density of the samples depending on how much organic matter was in them and how much was burned off. And then finally, to determine the inorganic carbon weight, I ran the samples in the furnace again, but this time at 1000 degrees Celsius for 4 hours. From all these previous measurements, I was able to determine the water content of each sample, how much organic matter was burned off during the LOI burn, as well as the amount of inorganic carbon burned off during the final burn. To determine the percent organic carbon from each sample, I used the following equation by Kraft, where C is the LOI weight taken from the dry weight, divided by the dry weight and multiplied by 100. You use a very similar equation to find the percent inorganic carbon, but you are taking the inorganic weight from the LOI weight while still dividing by dry weight times 100. So this first graph shows the percent inorganic and organic carbon from the West Beach Lake Core 3. The organic carbon in red varies from about 3% to about 40%, which you can see the percent on the x-axis and depth on the y, going from the top of the core down to the bottom. The inorganic carbon in blue ranges from about 2% to about 10%. And the Oliver Lake Core 1, the inorganic rate or inorganic percent of carbon stays at about 1% throughout the entire core, whereas the organic carbon varies from about 2% to about 35%. And it doesn't really have a discernible pattern. And in the Oliver Lake Core 2, again, the inorganic carbon stays pretty similar throughout the entire core, ranging from 0 to 2%, whereas the organic pattern carbon does not really have a pattern, but ranges from about 8% to about 54%. I placed all of the organic carbon amounts on the same graph to try and see if there was another pattern. And in the West Beach Lake 3 core and the Oliver Lake 1 core, there was a general decrease in the amount of organic carbon at the top sediments, which are the most recently deposited. This was not seen in the Oliver Lake 2 core. We hypothesized this decrease to be due to possible human influences, such as landscape changes that may have introduced inorganic sediments to the core, to the ecosystems. So some of the interpretations we made up from these graphs, most of them had to do with the West Beach Lake 3 core. For one, there was a noticeably higher amount of inorganic content throughout this whole core relative to the Oliver Lake cores, which we hypothesized to be due to marine influence, as this lake is at sea level, very, very close to the Puget Sound. There's also an anomaly at 55 centimeters of depth in the core, where there is a sharp decrease in the amount of organic carbon and a corresponding increase in the amount of inorganic carbon. We hypothesized this anomaly to be the result of a marine intrusion, such as a storm or even possibly a tsunami. Previous studies have found sand deposit evidence of what is hypothesized to be tsunamis on Whidbey Island, so it's not entirely improbable. The image on the right shows said sand deposit evidence. But of course, further research would have to be done to make any of these previously mentioned hypotheses certain. The next steps that I will be taking is prepping samples from the WB3 core to be analyzed for lead cesium dating. And in the following months, I will also be analyzing 3 other cores taken from West Beach Lake to determine their carbon content and see if there are similar patterns as we have seen here. If you have any questions, feel free to email me. Thank you so much for listening.